Hi everyone, today I'm going to discuss about Form 4 Chapter 3 Logical Reasoning. Our first subtopic is statement. So how do we determine a statement? If you know a statement is true or false, if you can determine a statement is true or false, then it is considered a statement. Example, when we talk about 2 plus 2 equals to 4, this is true. So if it's true, it's a statement. And we also know that 2 plus 3, it's given here as 4, and we know that it's not equals to 4. So this statement is false. So even though it is false, either it's true or false, it is still considered a statement. And if you can't determine the truth value, example, 2 plus 2. So you don't know whether 2 plus 2 is what, or you will say a plus 5. So you don't know whether a plus 5 is true or false. So when you can't determine the truth value, it will not be a statement. So I repeat, a statement must be either true or false. Only then we can consider that as a statement. Okay, next one is quantifier. For quantifier, it's divided into 2, all and some. So what you need to do is, when the question asks you about quantifier, you need to either decide whether it will suit all or it will suit some, depending on the question given to you. Number 3 is negation. Negation is using no and not. Okay, so if I write it as x is 2, the negation will be x is not 2. Or if I put it as equation form, x equals to 2, then my negation will be x is not equals to 2. Okay, so these are the first 3 things. Going to the next one, number 4. Number 4 is implication. For implication, first we need to know it has antecedent and consequent. Okay, so for antecedent, example of implication will be x equals to true if and only if true x equals to 4. So your antecedent is the first one, this is your antecedent, and this is your consequent. And from here, how do we restart our 2 implication? Implication 1, implication 2. So implication 1 and 2 both will use the word if and then. So you need to know implication means use if and then. So the first implication, if your antecedent, which is x equals to 2, then 2x equals to 4. Implication 2 will be, we are just going to flip them with your consequent first. If 2x equals to 4, then x equals to 2. So remember, implication is going to use if and then, and you need to write 2. The first one is antecedent followed by consequent. Second one, just you need to flip them. Okay, next. Implication is also divided into another 3 parts, which is original implication. I'm writing short form here. I'm just going to use the same one. If x equals to 2, then 2x equals to 4. So this is our original implication. Second one, we are going to talk about converse. For converse, we are just going to flip them, similar as our implication 2. If 2x equals to 4, then x equals to 2. Okay, third one, we will have inverse. For inverse, we are going to take back our original implication. Copy back the same thing. If x equals to 2, then 2x equals to 4. Once you copy back, you need to put not equals to. So you're not flipping them, you're just taking original implication and just adding not equals to. And the last one, number 4, is contrapositive. Contrapositive. For contrapositive, you need to flip them first, so similar as your converse. If 2x equals to 4, then x equals to 2. And once you flip them, you need to add not equals to. So implication and converse is a positive statement. Inverse and contrapositive is a negation statement where not equals to will come in. But inverse you don't have to flip. Contrapositive you need to flip. So this is the flow of implications that you need to know, the type that we have. Okay, let's see the next one. So if you see these notes, you can directly see from here, implication, this is our original. For converse, we already flipped them. For inverse, we have added equal sign, okay, this one. And the last one, for contrapositive, we flipped them and we added not equal sign. Okay, I left out something which is compound statement. After implication, let's see about compound statement. Number 4. Sorry, this is number 5. Number 5 is about compound statement. Compound statement is combination of two statements using or and you need to determine the truth value. So if we are using and, first statement correct, second statement correct, your final answer will be true. First one wrong and second one false. It will be false. If both are wrong, then it will be false. So what you need to know for true, for and, both must be true, both must be correct to get it as true. But for or, one correct, one wrong. Sorry, let's start with both correct first. So one correct and both are correct, it will be true definitely. One right and one wrong, it will still be true. Both wrong, it will be false. So for and, both must be correct to be true, but for or, both are right or either one is right, it will be true. So when we are combining statements, please check both your statement 1 and 2, whether it's true or false, to determine the truth value. Okay, so done with 3.1. Let's see 3.2. 3.2, we have arguments. First, you need to know our arguments are divided into two: deductive argument and also inductive argument. Deductive is going from general to specific. Inductive is going from specific to general. So example, I start with all even numbers are divisible by 2. And I'm going to say 4 is an even number and 4 is divisible by 2. So if you can see, they have started the statement with all. All is a general statement. It can be any even number that's divisible by 2. So you can see this is G, general. Then they have specified 4 is an even number, 4 is divisible by 2. So this is specific. So this is going from general to specific, which is your deductive argument. If we are going the other way around, from down to up, then it's from specific to general, which will be our inductive argument. This is how you differentiate the two types of argument. Okay, for next one, what do you all need to know is, okay, for inductive argument, the most important part, for inductive argument here, what you need to know is, it's divided into two, which is strong and weak. So inductive is from specific to general. Okay, so it can be either strong or weak. Sorry. be strong or weak. Okay, how do you know it's strong? Directly refer to your conclusion. So for inductive argument, they can ask you whether it's a strong inductive argument or a weak inductive argument. How do we determine whether it is strong or weak? It will be determined based on your conclusion. If your conclusion is true, then it's strong. If your conclusion is false, then it is weak. So once your conclusion is true, we will determine our next thing, which is cogent or not cogent. Okay, so for weak, if it's weak, it will directly become not cogent. Cogent means convincing, so it's not convincing. So once your inductive statement is weak, automatically it will become not cogent, not convincing. But if your inductive argument it is strong, where your conclusion is correct, then you need to determine whether it is cogent or not cogent. How will you determine whether it's cogent or not cogent? Here, if it's cogent, all your premise must be true. If any premise is false, premise 1, premise 2, or premise 3 is false, it will become not cogent. So let's directly see this part again. This is my map here. So if you can see here, if it is strong, means the conclusion is true. If it's cogent, means all premises are true. If any premises are false, then it will become not cogent. But if the conclusion is false, it will be weak and it will become uncogent or not cogent. Let's see an example here. Premise 1. Okay, let's directly go to conclusion. All multiples of 9 are divisible by 3. So is your conclusion true? Multiples of 9, 9, 18, 27, all are divisible by 3. So our conclusion is true. So once our conclusion is true, it is strong. So conclusion is true, it is strong. Next, let's check our premise 1 and 2. 27 is multiple of 9, yes, correct. 32 is multiple of 9, wrong. So for premise 1 is true, premise 2 is false. So one of the premise is already false, so it will become not cogent or uncogent. So due to premise 2 is false, it is not cogent. So your final answer is strong but not cogent. So if they ask you to explain why is it not cogent, you can specify premise 2 is false. So that is what you need to know for inductive argument. Inductive argument, strong, weak, the first part. Second part will be cogent and not cogent. That's all you need to know for inductive argument. Let's see the next one, which is deductive argument. Okay, deductive argument is divided into two parts, valid and not valid. Okay, so how do we know whether it's valid or not valid? Okay, first part, valid, it must fulfill the valid form of argument. So validity is depending, your validity is depending on the form of argument, which is divided into three forms. Form 1, form 2, and form 3. Okay, let me directly show you all. Okay, so here we have all three forms of deductive argument. If your arguments are fulfilling any one of these forms, that means to say it is valid. Let's see the first form. The first form states that all A is B. C will be A, C will be B. So an example, let's directly take this example. P1, all multiple of 6 are multiples of 3. Second one, P2, and your conclusion. Before you decide, let's decide from premise 1. This is your A and this is your B. And in your P2, 18 is multiple of 6. And in your conclusion, 18 is multiple of 3. Okay, so according to the rule, this is your A and this is your B. So what's your C? This is your C. And according to your rule, this must be A and this must be B. So if you can see, you have fulfilled the first form here. AB, CA, CB. So follow your sequence of A and B. What comes first? A and then is B. So this is fulfilling the first form. So this is considered valid. If I change this to 3 and this to 6, it will no longer be A and B. Your B will be here, your A will be here. So they are not following the sequence. So this will no longer be valid. Not valid. This is your first form. Okay, all A is B, C is A, C is B. Okay, let's see your next one. Your second form, P1, P2, and conclusion. So for second form, it states that if P, then Q. So let me give you an example. If X equals to 2, then 2X equals to 4. So here I'm going to put X is equivalent to 2, 2X equals to 4. So if you notice from this part, if P, then Q. So this is your P and this is your Q. So can you see this is your P and this is your Q? We have followed the sequence of P and Q. So this is considered valid as well, following your second form. If I would have added 2x equals to 4 and x equals to 2, then this would have been a Q, this would have been a P. It's not following your sequence of form 2, then it's not valid. So you need to know P first, only then Q. This is your second form. Okay. Your third form is very similar as your second form. So your third form states that P1, P2, and conclusion. So I'm going to take the same thing. If x equals to 2, then 2x equals to 4. So for this part, if you see your third form from here, we mentioned if P then Q, not Q is true, not P. So the addition word here is not. So if they had added the word not, this is your P and this is your Q. So if they had added the word not equals to, then we need to write our Q first, only then our P. We have to switch their position if this is in the form of negation, not equals to, or not 2x is not 4x is not 2. So this part, the second form, it is not negation, means it's positive x equals to 2, 2x equals to 4. So you write your P first, only then you write your Q. So this is valid following the sequence. But this one, we already added not equals to for both. So you need to put your Q first, only then your P. So this will be valid because it's fulfilling the third form. So if a deductive argument is given from general to specific, and they ask you whether it is valid or not, it must fulfill either one of these three forms. Okay, if it's fulfilling these three forms, either one of these forms, then it is valid. Okay, and now, other than valid, you also need to know whether your argument is sound or not. So let's see this part. So how do you determine whether your argument is sound or not? If all your premises are true, so once you determine whether it's valid or not, you need to determine whether it is sound or not. So if all your premises are true, then it is sound. If any one of your premises is false, then it will be not sound. That's all, okay? Okay, last one before I end. Let's say I give you premise 1, premise 2, and conclusion. If 2x equals to 4, then x equals to 2. My conclusion is x not equals to 2. Sorry, my conclusion will be 2x not equals to 4. How do you find your premise 2? Okay, when you are finding your premise 1, premise 2, or conclusion, cut whatever is whatever it's repeating, cut them off. So what is left? X equals to 2 is left. So we're going to write this here, but this is not equals to. So here also we will be putting it as not equals to. So this is how you write your premise 2 or conclusion. If these two are given and they ask you to combine into premise 1, example, I erase this right now. They gave you P2 and conclusion. They ask you to write premise 1. You need to know premise 1 is combination of your premise 2 and conclusion together. You're going to combine your P2 with conclusion. So if you can see your P2 is x equals not equals to 2, your conclusion is 2x not equals to 4. So you can either combine by using the word all or if then. So in these statements, we cannot be writing if all x equals to 2, then 2x equals to 4. Because not all x will be 2, right? So the suitable word will be if and then. So we will be replacing if x equals to 2. Okay, since now this is negation, not equals to, we are going to change back to equal sign again. So we're going to write our conclusion first. If 2x equals to 4, then x equals to 2. Usually our premise 1 is written in a positive statement without the word not, no, or not equals to. Okay, so that's all for chapter 3, logical reasoning. Statements, quantifiers, compound statement, negation, arguments, and also last one is implication. That's all you